Hello and welcome to another Physical Sciences 3 lecture. So we're looking at voltage in this lecture, and voltage, we can think of that as the energy in an electric circuit. So the energy in a circuit is supplied to the charge by a cell, battery or a generator. The energy is then carried by the electric charge as it moves around the circuit. It is then dissipated or used as heat, light, motion by electrical components. Okay. So we just have a little reminder here that the conservation of energy means that energy is not created nor destroyed, but transferred from one form to another. In this case, voltage is potential electrical energy that is transferred to the electrical components and dissipated in various ways. Voltage is sometimes referred to with two other names, so you may see these in some questions that come up for you. So we have electromotive force, and it is how much energy in volts is supplied to the entire circuit. Okay, and potential difference is how much energy in volts will be used between 2 points in a circuit by a component, and we also call this voltage drop as well. So the potential difference or voltage drop between the 2 points. It is important to recognize that. So I just move this back up there. It is important to recognize that voltage, electromotive force, and potential difference all share the same units. They are volts and are therefore the same quantity mathematically. Okay, so they all share volts. Volts are a derived quantity equal to the amount of energy in joules per coulomb. So remember, joules and coulomb are our SI units, with joules per coulomb here, but they are referred to as volts in this case. So voltage, and here's the equation for that. Voltage is equal to the change in energy over coulombs, so charge in coulombs. So we have a couple of examples we'll do now. So in example 3, we have 2 coulombs of charge flowed through a potential difference of 12 volts. How much energy was dissipated by the charge? Okay, so we just need to rearrange this equation. So the change in energy is equal to volts times coulombs charge, and we have 12 times by 2.0, which is equal to 24 joules. Great. So in example 4, if 0.15 coulomb of charge loses 3 joules of energy, through what potential difference has it moved? Okay, so what was the voltage drop between those? So volts are equal to the change in energy over charge, which is equal to 3.0 joules over 0.15 coulombs. So it's equal to 20 volts. Just remembering that joules per coulomb are equal to volts. Joules per coulomb, like that. Okay,